Welcome, ladies and gentlemen, to another Bentley David Tutors video. Today we're planning on talking about types of data if I make it that far. You might be able to see the lights are off. Jeremy's decided to cut the power after my previous statement stuff up. So hope.
Sound like maths to me.
No, it is maths. It is. Okay, I'll be right back. I'll be right back. Ah. Okay, after that brief intermission, Jeremy's decided to let me keep the power on. So I will actually be able to get through types of data and statistics. So yeah, hopefully it's not too long. There is a few things to cover because there's lots of different graphs and stuff. But yeah, I'll just get right into it. So firstly, we'll talk about the types of data. So first there's quantitative data, quantitative numerical, and that's the amount of a certain thing. So in this, there's two sections. There's discrete, which is a finite set of fixed values. So for example, there's like the number of goals in a soccer game or the number of people in a room. And then there's also continuous data, which is an infinite set of and it can be any value. So for example, this is like the height of the people in a class or the amount of rain that fell in a certain month. The next type of data is categorical qualitative, and these are the characteristics of a certain thing. So firstly, there's ordinal, and that is a category that has meaning when ordered. So for example, it could be clothing sizes, so you got like extra small, small, medium, large, etc. Or it could be birth months, so going in the natural progression of like January, February, March, and then again, etc. going on. The next one is categorical qualitative nominal, which is a category that cannot be ordered. So for example, dog breed, which is just, completely random and can be anything. And if you could order that, I would be very impressed. Okay, so the first type of graph we'll look at is simply a dot plot. So dot plots are used for quantitative discrete and categorical ordinal and categorical nominal. So all you need to know for this is that the columns should be neat and each point should be evenly spaced in matching rows. So you can see an example of a dot plot in the corner. It's quite simple. It's literally just stacking dots on top of each other. Yeah, so that's a pretty easy one. The next one is stem and leaf plots. So for this, you put certain values in the middle. Normally, it's the tens digit or hundreds digit. And then as you go down, each one across is the certain values. So as you can see on screen, it could be 5 and then another 5. So that'd be 55 and then a 6 next to that, 56. And then so on across and down the page. You can also have back-to-back stem and leaf plots, which is when you're comparing two different sets of data, which, for example, could be like comparing the scores in an English test and a maths test. And again, you'd have the same column and down the middle, and then have the values go across on both sides. There's another example of that in the screen now. The next one is a frequency distributions and histograms. So firstly, the information to do this graph comes from a frequency distribution table. And in this, there's normally 4 columns of this age group. You've got the score, or X. Next, you've got the tally, which is just how many times it's been counted. Then you've got the frequency, which is just how many times it's been counted, but in numerical form. And then you've got XF, which is the score times the frequency. Down the bottom of the frequency and the XF, you can do a sigma and then the total. Sigma just means total in the Greek alphabet or something like that. And then from that, you can figure out the average, median, and mode. So yeah, for example, you can see an example of frequency histogram on the left. It's basically a column graph, but at the same time, you have to start half a value away from the edge and leave half a value on the other side. This is so that the frequency polygon, which is the line that goes to the middle of the top of each point, has space to move throughout the graph and start and finish at the 0 point. Also, you need to make sure you've got a scale and titles on both axes. And frequency histograms and polygons are only used for quantitative data only. I know that probably wasn't the most clear explanation, but I'm trying to keep it a bit shorter. Also, with that, you can have grouped frequency distribution graphs, which is where there's a group of values, so say you're doing people's height, you might not want to do every digit from 160 to whatever 180. So you could do 160 to 164 as one group, and then go on in fours throughout until you reach your highest digit. For this, you would want to, on the graph, you want to be plotting the class center, which is just the number which is in the center of the two end values of that group. Next, we've got measures of centrality. So measures of centrality are statistical values that give us information about the middle of the data set. So firstly, there is the mode, which is the most common. It's not as useful for the middle of the data, but it's very useful in business as it shows you, which circumstances are happening the most and other stuff like that. Next, we've got the median, which is the middle value of the data set. To find the median, you need to get all your data points and put them in ascending order. And then if it's an odd number, you find the number in the middle. So if you've got 9 numbers, it'll be the 5th number, because then there's 4 numbers less than it and 4 numbers more than it. If there's an even number, you've got to get the 2 numbers in the middle. So say you've got 2, 3, 4, 4, 5, 6, 7, 7. You need to get the 4 and the 5 as they're the 4th and 5th number, and then average them out to get your median, which would then be 4.5. And finally, in measures of centrality is the mean, and this is just simply the average. So you put the sum of all the samples over the number of samples, and then just divide that and you have your average or mean. Next, we have measures of spread. So a measure of spread tells you about how these scores are distributed. So firstly, there's the range, which is the total span of the data. So the range equals the max score minus the minimum score. So say we've got the scores again, 2, 3, 4, 4, 5, 6, 7, 7, 8. The range would equal 8 minus 2, as that's the highest and the lowest, and then therefore the range is 6. Next, we have the interquartile range. A quartile is when you divide the data into 4 equal parts. So with the set we've been working with 2, 3, 4, 4, 5, 6, 7, 7, 8, you'd have your median of 5, and then you'd put the lower quartile split with the 3 and 4. So again, average that out because there's an even number. So it's 3.5, and that's the lower quartile. And then the upper quartile is the split between 7 and 7. Average that out, and it is still 7, believe it or not. And then the interquartile range is the upper quartile minus the lower quartile, which is 7 minus 3.5. Therefore, the interquartile range is 3.5. Again, that wasn't probably the most clear, but I've put examples up in the corner, so hopefully that makes it a little bit more clear. Okay, so next we've got box and whisker plots. So to do this, you need to generate a 5-point summary of the data. So this comprises of firstly the minimum, the lower quartile range, so QL or Q1, then the median, upper quartile, and the maximum. I realize I said lower quartile range, but that's wrong, it's just the lower quartile. So to create a box and whisker plot, you need to firstly put a scale of all the numbers in your set of data, so 1 or whatever your starting value is to the end value, and then put a vertical line at each point of the 5-point data set. Then at the end, then you want to draw a line from the first point to the second point. Then from there, you want to draw a line that goes up and a line that goes down. I know this isn't clear, but there's the example in the corner, and you can probably sort of get what I'm getting at. So like a box, and it's got like whiskers coming out of it at the end. Yeah, that's just quite simply what it is. Finally, or not finally, but next we've got a few other graphs which are pretty simple. So we've got a sector graph, which is just one of those old-fashioned pie charts where it's split based on the number there are. And then there is also a column graph, which is pretty much the frequency histogram, except there's no gap left between the end and the start. And then there's finally a bar graph, which is it's a flying Jeremy. So this is a rectangle which is divided into parts, which represent each percentage of your value set. Finally, we've got comparative data. So here you need to look at the shape of the distribution of the scores. So there's 4 main points to talk about here. Firstly, symmetrical. So here it's you've got one single mode, so one peak in the scores, and the median should roughly equal the mean. Next, there is a bimodal graph, which is when there's 2 modes, which gives you sort of like a peak, 2 peaks. Next, we've got negatively skewed data, and this means that it starts off low. It's got like a tail going to the left, and then it peaks close to the end. And this generally means that the median is less than the mean. sorry, the median is greater than the mean. And finally, there's positively skewed data, which is just the opposite of negatively skewed. It starts high and then the tail comes out at the end. And this means that the median is smaller than the mean. Yeah, so here just look at the median, mean, and mode, which again is the measures of centrality, range and interquartile range, measures of spread, and also outliers. And just make sure you're talking about those if you need to compare data. It's just the easiest way to go around it rather than just describing it. It's probably more likely to get those marks. And make sure you're always including the actual numbers in your written comparisons. So, for example, the average of the test data from the second exam, bracket 15, bracket, was greater than the first test, bracket 12, bracket. That's all I'm going to talk about because the video is already over 10 minutes and we're trying to keep them all under 10 minutes. But yes, I was pretty brief, so hopefully you have the time to go and look at your own study for statistics, but hopefully this helped you in some way or another. If you enjoyed the video or learned something, leave a like and subscribe. And again, keep an eye out for the many videos which have already come out and will continue to come out.